Hello, we are going to work on some of the questions in this AMC10A that was on November 8th, that is last Wednesday. And I got this question, and I noticed that there's 75 minutes, you have 75 minutes to finish 25 questions. And for people, you might want to know that most kids take this AMC 10 is either 9th or 10th grade, or less than 17.5 years old. All right, the first questions are easy, and the later the question level, the difficulty level gets harder and harder. So we are going to, I see that on page 1, on this first page, there are 8 questions. So we're going to work on these 8 questions. I'm going to show you how to work on those questions if you know math, or if you use the school math to work on the question. And also I will show you the other way, which might be a little easier, I guess, to figure out the answer, because this is a multiple choice. So to get the answer faster and correct, that's the most important thing. All right, now we're going to start. We start with question number 1. Cities A and B are 45 miles apart. So that gives this. That's A, and this is B. Okay. Then Alicia lives in A and Beth lives in B. So two persons, A and B, lives in the city. And Alicia bikes towards B at 18 miles per hour. So her speed is 18 miles per hour. And living at the same time, Beth bikes towards A at 12 miles per hour. Okay, so if they going to bike towards some middle point, and then they're going to meet somewhere, the question is, how many miles from city A will they be when they meet? So they ask for this distance. Okay, let me tell you what the school will ask you to do, or if you learn things at a school. So you probably, this is 45 miles, you probably will say, well, we have the formula. The formula is distance equals speed times time, or time is distance divided by speed, or speed is distance divided by time. So that's a formula. And when A goes from here to the midpoint, not midpoint, to this meeting point, and then B goes from here to the meeting point, there's one thing in common. One thing is the same. That is the time. So how long it takes from A to get here. So let's see. Let's assume the question they ask for is x. So therefore this part should be 45 minus x. And then x is the distance for A, and here's the speed. So distance divided by speed will be the time. So that will be x divided by 18 equals to 45 minus x, which is the distance that B travels, and then divided by her speed. So this is the equation, right? It's a linear equation pretty much. So you're going to either multiply or do whatever you want to do to solve it. So we can multiply by the least common denominator number for both sides, which is 36. So that canceled out, you get a 2, and that canceled out, you get 3. So 2x equals 45 minus x times 3. And then you distribute this into this parenthesis. So 3 times 45, so you have 135 minus 3x. And then you're going to plus a 3x on both sides. You get a 5x equals 135. Therefore, x is 27. That's your answer, E. Okay, and there's another way to do it. If you think A travels from A point to this way 18 miles per hour, and B travels at 12 miles per hour. After 1 hour, then the distance between these two persons will be shortened by what? By the 30 miles, right? Because 18 and 12. So you do 18 plus 12. That is a 30, and that is a 30 miles reduction in the distance per hour. And then total is a 45 because they have to travel all the way till they meet. So that would be 45 divided by each hour reduced by 30 miles. Then that is 1.5 hour. Okay, so both traveled 1.5 hour towards this point. And then A travels at 18 miles per hour after 1.5 hours. So for that 1 hour, she traveled 18 miles. For this 0.5, she travels 9. So that will be 18 and 9. And that is 27. So you get exactly the same answer. The first question, the answer is E. Okay, that's the first question. So now you see the little difference, or you see some difference. This is the school math. That's what you're going to learn at school. And this is a quick way of thinking, so you can just get the answer much faster. Okay, most of the questions are like this. So if you work on those math competitions, you're going to see a lot of questions like this. Once you know how to think fast, that will save you a lot of time. Now the second one. Second question, the weight of 1/3 of a large pizza together with 3.5 cups of orange slices is the same as the weight of 3/4 of a large pizza together with 1/2 cup of orange slices. A cup of orange slices weigh 1/4 pound. What is the weight in pounds of a large pizza? So we're looking for the weight of a pizza. So we just assume that the pizza, one pizza's weight is P, and the 1 cup of orange slices. I always feel like reluctant to use the letter O to show that, because I don't want to get confused with the 0. So I just use S. This is orange slices. Then the first one, let's translate this thing from English into math. That would be 1/3 P plus 3.5 S, right? So that's 1/3 of a large pizza with 3.5 cups of orange slices is the same as the weight of 3/4 of large pizza, and together with 1/2 cup of orange slices. So we get this equation, and we are going to simplify this a little bit by moving the S to one side and get a P to the other side. And the reason I do that is here's a 3.5, here's 1/2. So if you move that to here, or there are two ways to say it. One is you subtract a 1/2 S on both sides, or you just move this to the other side and change the sign. It's the same thing. So then I get a 3S equals, the right side I have a 3/4 minus 1/3 P. All right. Okay. So, and there's one more information I have is this S is 1/4. Therefore, I have a 3/4, which is the left side, equals, and the right side I find the least common denominator, which is 12. So that will become 9 minus 4 P, and that is 5/12 P. All right, so I have this equals this. Therefore, the P will be, I multiply by the reciprocal of this, so that is a 3/4, the left side, multiplied by 12/5. And then I cross this, I get 9. Here's a 3, right? So 3 by 3, I get 9. So that is 9/5. We look at the answers to see which one is very close to 9/5, or is the same, which is 8. So this question, the answer is A. Okay, sounds good. There is another way to do that. There's another way to do it. Is you use the least common denominator. You find the least common denominator first. So you can write 3P, well, P/3 plus 2, and the 3.5 is a 7/2. S, that equals 3/4P, and then plus 1/2 S, right? So you can multiply by what? The least common denominator is 12. So let's multiply by 12 on both sides. So I have a 4P plus, and this multiplied by 12, you get a 6/7/42S equals. Then we have 4 cross out with this 12, I get a 3, so I have 9P, and it equals 6S. here's a S, here's a P. So I bring this P to here, so I have 5P, right? So 9P minus 4P. On the other side, 42S minus 6S, I have 36S. And we know S is what? 1/4. So this is 36 times 1/4. That is 9. So 9 equals 5P. So I got a P equals 9/5. It's the same thing. So if you're not very familiar with this, then you can just multiply by the least common denominator or least common multiplier first to get the answer. So this is a question 2. So you can tell it's interesting, isn't it? Now number 3. Number 3 is how many positive perfect squares less than 2023 are divisible by 5. Now how many positive perfect squares? For all the positive numbers, we might have 1, 2, 3, 4, 5, right? And this is all the way to 2023. And how many of them are perfect square? Perfect square was like a 1, and 2 squares are 4, 3 squares 9, and a 16, 25, and etc. Right? So for how many perfect squares like this are divisible by 5? If x squared is divisible by 5, then x must be divisible by 5. That's for sure. If a number square is divisible by 5, then that number must be divisible by 5, because otherwise it doesn't happen, doesn't exist. You can prove it. And so far we are looking for the number in the original sequence. In this original sequence, we're looking for how many of them are divisible by 5 but less than square root of 23, isn't it? Because we're looking for take the square root of each number, and we ask for how many numbers are less than this but also divisible by 5. Okay, so now the hard part is how do you find the square root of 2023? There are 2 ways to do it, and I guess that you're at a school, maybe the teacher, I don't know which grade, but the teacher might show you how to get the square or how to estimate a square root when you're given some number. But I want to tell you a little trick here. Okay, this is the little trick that will help you later if you calculate something with a 5 at the end, a square like 5 square. So that would be just 25. You know this. And 15 square. Okay, for 15 square, things like this, you just use this number, which is 1, multiply by the number next to it, or the number 1 greater than that. That'll be 2. So 1 times 2 is 2. And then just put a 25 at the end. That'll be your answer. So for 25 square, it's the same idea. You just use this 2 times 1 more than that, which is a 3. So 2 times a 3, that's a 6. And then put a 25. Okay, so 35 square, you're going to use this 3 times a 4, that is 12. Then put a 25. Okay, so how about a 45 square? 4 times 1 greater than 4, 5. So 4 times 5 is 20, 25. Wait a second. I got a 2025. I need to look for the square root of 2023. So this 2023 is just slightly less than 2025. So the square root of this must be somewhere very close to 45, but no, not there yet. So it should be like a 44 point something, right? I don't know what is that. I don't care. Now I'm looking for how many numbers from 1 to 44 are divisible by 5. And I can list them actually. That would be 5, 10, 15, 20, okay, 25, 30, 35, 40. And no 45 because I only add 44 something. So that is total 8 of them. So the answer for this question is 8. And that is the answer for the question number 3. So I hope that you can remember this little trick. You can keep going like a 55 square. That will be 5 times 6, 30, 25. And a 65 square is 6 times 7, 42, 25. So if you have question like this in the quiz, that will save you little time, right? And one important thing is you cannot find the square root of 2023 by calculator, because this AMC10 you're not allowed to bring the calculator in the test. Okay, and let me finish this. 85 squared, that will be 8 times 9, 72, 25. Okay, and 95 squared will be 9 times 10, which is 90, 25. I think that'd be good enough for you to remember. Okay, so this is question number 3. So far you had fun? Huh? Number 4. Let me make it like that. Okay, a quadrilateral has all integer side lengths, a perimeter of 26, and one side is of length 4. What is the greatest possible length of one side of this quadrilateral? So it's a 4-sided shape, right? Like that. All right. So one thing we know the perimeter is 26, and also I know one side is a 4. I guarantee you that this is not the largest. If this is the largest, then the other 3 sides will have the length no more than that. So the most you can get is a 4 by 4 by 4 by 4, plus them you get a 16. So this is not the longest one. So it could be either here or here. It doesn't really matter. And if we're looking for one side to be really the largest, and we are looking for, if you move these 2 points towards like opposite direction, and then this goes down, so you're going to have something kind of like a really flat, like that, right? It's really flat. It's like pretty much the extreme case almost. The extreme case is going to be, it's so flat that it's a one line. All right, so that means this length, the longest side, the length gets really, really close to 1/2 of the perimeter, because the perimeter is the sum of all 4 sides. So let's see, half of that is 20. Half of that 26 will be 13. If this is a 13, and then what is the length of the other 3? I have 1 4, so I probably will have the other. So here is the 13, so this 3 will add up to 13, which is not a good thing, because then you're going to have a really flat, they kind of like come down to the bottom line. So that was not a good quadrilateral. So 13 is no good. And then we have to reduce that to 12, because it has to be integer. So we go down by 12. This is, we think it might be the longest, right? And let's see whether it's possible. This is a 4, this is 12, that's already 16. And the total should be 26. So I can have a 5, a 4, and a 5. This could be the case. That will give you the maximum length of the longest. You might think, well, is this a 4, 5, 5 work? Does that work? Of course. Why not? Okay. So anyway, we got the same answer. This quadrilateral, the greatest possible length of this longest side is 12. So the answer is D. That's number 4. Okay. And number 5. Let's work on number 5. How many digits are in the base 10 representation of 8/5, 8 to the 5th, 5 to the 10th, and 15 to the 5th? So you might have learned the exponents, and at least you have to know power, right? When you are young, you have learned a power. I'm not sure about the what course you have learned, but this is okay. All right. And there's several properties. We have a to the m times b to the m, and that's the same as ab to the m, right? That's one of the property. And we have, what's the other thing? We have a to the m times a to the n, which is a to the m plus n. Okay, there are several properties of that, but for this one, you have an 8, you have a 5, you have a 15, and we talk about how many digits. There's one thing I noticed is for every pair of 2 and 5, that is a 10. Okay, So let me figure out how many 10s are here. Let's see what happened. This 8. 8 is 2 cubed, so that's 2 by 2 by 2. So 8 to the 5th. 8 to the 5th, that is 2 by 2 by 2 to the 5th, or 2 to the 3rd, and then to the 5th, that is 2 to 15th. So I write that as 2 to 15th power. And the next one is 5 to the 10th power. And this 15 is 3 by 5, so that becomes 3 to the 5 and 5 to 5. And then for this and this, I combine that, will be 5, 15, and then 3 to the 5. So we have a 10 to 15th power. Okay, and then times 3 to the 5th. What is this? That's 15 zeros, and then with a 1 at the beginning. So this 3 to the 5th is whatever number is just goes here. So 3 to the 5th is 3 by 3 by 3 by 3 by 3. And this is 9. This is 9. So that is 81 times 3. That will be 243. So the answer is 243 times 10 to 15th. How many zeros? 15. So 15 zeros, 16, 17, 18. So the answer is 18. So that's E. There are 18 digits of that. That's number 5. Sounds interesting? All right, now number 6. Let me move this up a little bit. Okay, number 6. An integer is assigned to each vertex of a cube. The value of an edge is defined to be sum of values of 2 vertices it touches, and the value of a face is defined to be the sum of the values of the 4 edges surrounding it. The value of the cube is defined as the sum of the values of its 6 faces. Suppose the sum of the integers assigned to the vertices is 21. What is the value of the cube? Okay, there are 2 ways. There's always like 2 ways. There are 2 ways to do it, at least. Okay, so at the side, which we don't really see this cube, the other side, I guess you can see that. All right, so for each vertex, you're going to assign a number. The number, they said, an integer. So there are 8 numbers. And then for this number, add up, you're going to get the value of this line. Okay, so you get this line, this line, this line, you get all those 12 lines. And then for this, for this 4 line, you add up their values, you get the value of this face. And then for all those 6 faces value, you add them up, you get the value of the cube. Okay, now here is the thing. Let me tell you the first way. You assign a number here. You assign a number here, all right? So far, let's just assume that you give the value A to this number. It's an integer. And then let's see what happened. Let's see how many times you're going to get A at the end. So for this line, you have 1A, right? You have a 1, because this one, I don't care what is that. It's going to be A plus that. So this A occurred here once, twice, 3 times. Is that right? So A just occurred like that. So for this one with this line, this two, they don't. But this face, the face I'm showing you here, that will have 2A, isn't it? That will have 2A. Okay, make it darker. So therefore this also have 2A, and that also have 2A. Now if you add all the 6 faces values together, you get the value of this cube. 6A will be there, because 2A, 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 so you're going to have 6A. So that is, if you assign a value A here, at the end, if you calculate the value of this cube, you're going to have 2A. The same thing happened to this point, this point, this point, this point. So all the points value will add up to, is that 21? 21. and then times 6. So the answer is 12, 6 is 126. That will be, the answer will be D. Okay, I tell you another way to do it is give that a extreme, extreme situation, extreme case, because they only say integer. So let's assume this is 21. This number is 21. And everywhere is 0. Everywhere else is 0. Would that be easier? You can do that. There's nothing wrong with it, because the final answer will be a fixed number. So if this is 21, so here's 21, here's 21, here's 21. Make sense? And everywhere else is 0. And then this is 21, 21, so this side is 42, this side is 42, and this side is 42, right? And then all the other faces has the value 0. Now you add this 6 faces together, that'll be 42 plus 42 plus 42. So you are getting 126, exactly the same answer. So I think this one might be easier way, because I would use this way if I start working on this question. So that is number 6. Number 7. Number 7. Okay. Janet rolls a standard 6-sided die 4 times, number 7, and keeps running total of the numbers she rolls. And what is the probability that at some point her running total will equal 3? All right, now here how it works. This is the first die, this 4 times, or first time, second time, third time, and a fourth time, right? And then if you get a 1 here, and she is going to write 1, okay? If you get a 1 again, she's going to write a 2, because she's keeping the running total. If here's a 1 again, she will write 3, and this is the 3. Just give you one example, she's going to 6. All right, so those are the totals that she's going to get. Okay, so how do you get a 3? There are only limited situations. That would be, you get a 3 at the first, okay, and then so she has a 3, and then everything after that, it doesn't matter, because it's going to be much, much greater than 3, so we don't care. And then so what is the chance to get the first 3? That's 1/6 of all the possibilities, right? And after this, and how do you get 3? You can get a 1 and a 2, or 2 and a 1. Because if you keep writing the total, it's going to be 1, 3, and something. Or 2, 3, and something. See, that's how you get 3. So that is 1/6, 1/6 chance. So that will be 1/36 chance. And this one is also 1/36 chance. So that's 1, 2, 2, 1. And the other situation is this, 1, 1, 1. So this is 1/6 of the chance, 1/6 of the chance, 1/6 of the chance. They're independent of each other, so we use the multiplication. So to get the probability to get a 1, 1, 1, whatever is 1/6 to the third, or 1/6 by itself 3 times, so it's 1/216. All right, so we have this 4 situation. We just need to add them up. We have 1/6 plus 2/36 plus 1/216. And if you want to add this number, then you multiply by the least common denominator, right? You change that into the denominator. It's going to be 216. So from 6 to 216, you multiply by 36. From 36, you go to 216, you multiply by 6. So this 2 becomes 12. And here is just 1. So the answer is 36, 12, that's 48, plus 1 is 49/216. And that is your answer B. Okay, so this is question number 7 if you want to read that. Okay. All right, so let's work on the last one on this page. I hope that you can find these math questions very interesting. Bob the baker has developed a new temperature scale for her bakery called Bretta's scale, okay, which is a linear function of the Fahrenheit scale. bread rises at 110 degrees Fahrenheit, which is 0 degrees on the bread scale. Okay, bread is baked at 350 degrees Fahrenheit, which is 100 degrees on this scale. Bread is done when its internal temperature is 200 degrees Fahrenheit. What is this in degrees on bread's scale? All right, now this is a very, very typical linear equation or the linear relationship question. So for the Fahrenheit, here is 110 degree, and here is 350 degree, and this scale, the bread's scale, here is 0 and here is 100. All right, so they're like a linear, they have linear relationship, or they have like this relationship. Therefore, what are we looking for? 200 degree. So here, 200 degree here. We ask for what is the corresponding degree in this new scale. You see that? All right, now how should we do this? We look at the distance from 120, that is 90, and from 200 to 350, the difference is 150, and divided by 30, so the ratio is 3/5. Okay, so is that right? Okay, so that's a 3/5. From 0 to 100, we cut here, or we're looking for this degree, and the ratio is 3/5. So that's, you break this 100 into 8 pieces, and you count where it is at the end of the third piece. So that'll be 100 times 3/8, and that is 12.5 times 3. So the answer is 37.5. Okay, so that's B. Let's do that. 37.5. The answer is D. Okay. All right. So this is my way to do this question. I think it will be easier. Just use the proportion or the ratio, and that'll be the easier. So you can just control and to find it. And so that is the first 8 questions. I showed some answers in the school math way. That's what you learned at school. You learn some formulas, you remember something, and you keep working, you get the answer. Or there's another way, sometimes it might be easier and faster. So for these 8 questions, they shouldn't take you, if you think like in my way, then they shouldn't take you more than like 8 or 10 minutes to finish them. It should be very fast. So let me know if you think this is interesting. Sometimes you probably didn't realize that the math is so much fun, but if you do, please let me know. If you want me to show you how to solve the other questions. It just gets harder and harder. I think for some of them it took me a little bit time to figure, but at the end I get all of them. So it was an interesting question for me. It was a it's fun thing to do. But if you think this is interesting, do let me know. Okay. And I hope that you're going to like math, or you think math is not that boring. It's something very interesting. At least I found that interesting. All right, thank you. You can leave a note. You can leave a comments down below. And if you think this is interesting, you might want to forward this video to your friends who likes math, or you can share that with your friends or siblings to see whether you can have some discussion together if you do like math. Thank you.